Mercury. Mercury is the closest planet to the Sun, but if you think that means it's always scorching, think again. During the night, temperatures plummet to a bone-chilling minus 180 degrees Celsius, while during the day they skyrocket to a brutal 430 degrees Celsius. This wild swing happens because Mercury has almost no atmosphere to trap or distribute heat, just a thin, wispy exosphere that does virtually nothing. But temperature isn't your only enemy here. Mercury gets hammered by nearly 7 times the solar radiation that Earth does, meaning your suit would be fighting a losing battle against particle bombardment from the moment you arrive. The terrain doesn't help either. The surface is riddled with ancient craters, steep cliffs, and jagged ridges left behind from billions of years of asteroid impacts. Landing would be incredibly treacherous, especially without air resistance to help slow your descent. Current NASA spacesuits can only handle temperatures up to about 121 degrees Celsius, barely a third of Mercury's daytime peak. Your best survival window? A thin strip called the Terminator Zone, the boundary between the sunlit and dark sides, where temperatures are slightly more forgiving. But even there, you'd have minutes at best before the relentless radiation and temperature shifts begin to win. Venus. Venus might look beautiful from space, a shimmering pearl swathed in golden clouds, but it is arguably the most hostile surface in the entire solar system. Those gorgeous clouds? Sulfuric acid, dense enough to dissolve metal. As you descended through the atmosphere, visibility would vanish almost immediately. The air itself is about 96% carbon dioxide, thick and oppressive, and by the time you approach the surface, you'd feel like you were sinking into a heavy, smothering blanket. The temperature holds steady at around 450 degrees Celsius day and night, hotter than Mercury's daytime peak despite being nearly twice as far from the Sun, because the runaway greenhouse effect traps every bit of heat. Atmospheric pressure at the surface is 92 times that of Earth, roughly equivalent to being 900 meters underwater. Even the most advanced suit ever designed would be crushed like a tin can within seconds. Only about 10% of sunlight ever reaches the ground, so it's dimly lit and deeply unsettling down there. In short, Venus gives you heat, darkness, suffocation, crushing pressure, and acid all at once. Mars. Mars is the most Earth-like planet we know of, and yet it would still kill you in dozens of creative ways. During summer days near the equator, temperatures can reach a surprisingly mild 20 degrees Celsius, but at night they plunge to minus 73 degrees Celsius, and in the polar regions it drops far colder than that. The atmosphere is thin, about 1% the density of Earth's, composed almost entirely of carbon dioxide, meaning one breath outside a suit and you'd lose consciousness within seconds. That thin atmosphere also offers almost no protection from radiation. Mars receives between 40 and 50 times more radiation than Earth's surface, and solar flares can spike that dramatically. Then there are the dust storms, some of the most violent in the solar system, covering entire hemispheres for months at a time, with winds hitting 100 kilometers per hour that carry fine abrasive particles capable of clogging equipment and degrading materials over time. Any serious attempt at living on Mars would require airtight habitats, heavy radiation shielding, and a reliable source of oxygen and water. It's the closest thing we have to a second home, and it's still trying to kill us. Jupiter. Jupiter is a planet that kills you before you even get close. Starting about 300,000 kilometers out, the radiation belts surrounding it are so intense they would penetrate virtually any shielding we currently possess and cook you alive from the inside out. But let's say you have a miraculous suit that handles all of that. As you entered the upper atmosphere, you'd be greeted by bands of frozen ammonia clouds at temperatures around minus 150 degrees Celsius, lashed by winds screaming at over 480 kilometers per hour. Descending further, the pressure and temperature climb rapidly. The famous Great Red Spot, a storm that's been raging for centuries, is just one of thousands of violent atmospheric systems swirling around you. Past about 150 kilometers depth, where NASA's Galileo probe stopped transmitting in 1995, things get genuinely alien. The gases begin transitioning into a supercritical fluid, neither quite liquid nor gas, and you'd essentially be swimming through it. Deeper still, metallic hydrogen forms under the unimaginable pressure, conducting electricity like a metal. The core temperature may reach 24,000 degrees Celsius, roughly 4 times hotter than the surface of the Sun. There is no landing on Jupiter. There is only sinking and eventually being erased. Saturn. Saturn is gorgeous from a distance, but approach it and you immediately realize the beauty is entirely deadly. First, you'd have to navigate 146 known moons, some of which orbit in chaotic, unpredictable paths. And then you'd hit the rings, which sound peaceful, but are actually fields of debris ranging from tiny ice pellets to chunks the size of houses, all hurling at orbital speeds. If you somehow threaded through that gauntlet and aimed for the equator, you'd witness dazzling red and purple auroras caused by energized hydrogen. Right before hurricane-force winds at 1,800 kilometers per hour tore your spacecraft apart. Approaching from the poles is no better. A hexagonal storm larger than 2 Earths sits locked over the North Pole, surrounded by ammonia clouds and temperatures plunging to minus 250 degrees Celsius. As you descended deeper, the cold would ease, but the pressure would replace it as your new nightmare, eventually matching the crushing depths of Earth's deepest ocean trenches. At Saturn's molten rocky core, temperatures reach 11,700 degrees Celsius, more than twice the surface temperature of the Sun, under pressures roughly 1,000 times greater than Earth's surface. Uranus. Uranus is the oddball of the solar system, the only planet that rotates on its side, essentially rolling around the Sun like a spinning top knocked over. Its day lasts just 17 Earth hours, but a year takes 84 Earth years. Despite being called an ice giant, Uranus isn't actually a solid ball of ice. The term refers to the composition, heavy elements like water, methane, and ammonia ices mixed with rock, rather than the lighter hydrogen and helium that dominate Jupiter and Saturn. As you approached, you'd first have to survive the faint but a real ring system, then plunge into an atmosphere that holds the record for the coldest measured temperatures in the solar system, dropping below minus 224 degrees Celsius. The upper atmosphere is eerily calm by gas giant standards, but descend far enough and you'd hit dense, toxic layers of hydrogen sulfide that smell like rotten eggs. Further in, the pressure builds to around 100 times Earth's atmospheric pressure, and diamonds, real diamonds, form from compressed methane and rain downward through the interior. It's a planet of extremes disguised in a pale blue-green calm. Neptune. Neptune is the last planet in our solar system and in many ways the most extreme of the ice giants. It sits 30 times farther from the Sun than Earth, meaning sunlight arrives so faint that it barely makes a difference to the temperature. Yet despite being so far from any heat source, Neptune has some of the most ferocious winds in the solar system. Supersonic gusts that have been clocked at over 2,100 kilometers per hour, fast enough to outpace a rifle bullet. The outer layers are bitterly cold, but the deeper you go, the hotter it gets, because Neptune generates significantly more heat from its own interior than it receives from the Sun. Its core sits at around 7,000 degrees Celsius, hotter than the surface of the Sun. Like Uranus, Neptune produces diamond rain deep within its interior, where methane molecules are torn apart by crushing pressure, and the carbon atoms link together into crystalline structures that sink toward the core. It's a world that is simultaneously freezing and scorching, calm on the outside and violently alive within. A fitting end to a solar system full of lethal surprises. If you liked this video, subscribe for more.